Folks, we got a crazy one today. All right, so we got the number 2010 squared. Now we're going to randomly pick two of its divisors and then find the probability that those divisors are perfect squares. Let's check out the answer to the 2010 number 1 AIME 1 problem solution.
ABC, learn with me.
Alright folks, let's check out the first problem in the 2010 AIME 1. This was requested by Matt 3.1415. Thanks for the request. Let's check it out. So Maya lists all the positive divisors of 2010 squared. Okay, so let me just write that out. 2010 squared. She lists out all the divisors. So for now, I'll just call it D1, D2, D3, whatever, right? D1. Okay. She then randomly selects two distinct divisors from this list. So she randomly selects two of them. Okay. Okay, now what? Let P be the probability that exactly one of the divisors is a perfect square. Okay, so the probability that one of these guys, let's say this one, is a perfect square is given by P. Okay, now what? The probability P can be expressed in the form M over N. All right, so we can also write this as M over N, where M and N are relatively prime. All right, that just means it's simplified. Okay, find M plus N. So, all right, what we got is this. We got all the factors of 2010 squared. We take two of them at random, and the probability that one of those two is a perfect square is M over N. So we got to find that probability. How do we do that? Well, first we got to find out how many members are in this list. How many divisors do we actually have? Well, that's not too bad. That's the first question we have to answer. How many divisors does 2010 squared have? Okay, after we know how many divisors it has, we have to randomly select two distinct divisors from that list. Okay, so how do we do that? How do we mathematically express that? Well, when you randomly select two things out of n items, you can write that as n choose 2, right? So let's say the answer to this question is D. Well, our next question is, how many ways are there to randomly select two distinct divisors from this list? Two distinct divisors from the list. And why are we doing that? Well, because that's what the problem asks us to do. She randomly selects two distinct divisors from the list. Okay, after we figure out that, the answer to this question is going to be our denominator, right? The denominator, this n over here, represents the total number of ways we can pick two things from the whole list of divisors. What's our m going to be? Our m is going to be the number of divisors that are perfect squares. And pretty much it. Okay, so let's try to answer our first question here. How many divisors does 2010 squared have? How do we answer that question? Well, we got to prime factorize 2010 squared. So to factorize 2010 squared, let's factorize 2010. So what goes into 2010? Well, you can imagine it's going to be 2 and 1005. 5, as you can imagine, goes into 1005 as well. So 5 times, let's see, 201. Yep, I think so. And let's see, 3 goes into 201 how many times? 6, that's going to give me 1. Okay, so 67. So these right here are the prime factors of 2010. Okay, so 2010 can be written as 2 times 3 times 5 times 67. So it stands to reason that 2010 squared would just be square of that. Okay, not too bad. Now, how can we figure out the answer to the first question? Well, we still don't know how many divisors 2010 squared has. We almost do. Check it out. Remember that the total number of divisors is given by 1 plus the exponent of the prime factor and multiply that by all the prime factors. So let's do that. So what's the exponent for our first prime factor? Well, for all of them, it's going to be 2. So we got 2 plus 1. And how many prime factors do we have? We have 4 of them. So 2 plus 1 to the 4th power, that gives us 81. All right, so now we know the answer to the first question. 2010 squared has 81 divisors. Okay, well, how many ways are there to take 2 numbers from 81 numbers? Well, it's just going to be 81 choose 2. And that, ladies and gentlemen, is going to be our n, our denominator. It's going to be 81 choose 2. So let's write that down. So m over n, whoops, we got m over n, and we already know what n is. N is going to be the total number of divisors, 81, and we're choosing 2 of them. Okay, now we got to find the probability one of those 2 divisors is a perfect square. Well, how many perfect square divisors does 2010 squared have? Let's write them down. 2010 squared. All right, so 2010 squared. How many perfect square divisors does it have? How many perfect square divisors does it have? Does it have? All right, well, let's write them all out. The first one may be the easiest. Oh, and don't forget the prime factorization is 2 squared, 3 squared, 5, oh, sorry. I'm running out of space here. 5 squared and 67 squared. Is that right? 2, 3, 5, 67? Yes, sir, it is. So how many perfect square divisors does this guy have? Well, let's write them out. Let's see, how many perfect square divisors? Well, the first one is maybe the easiest, 1. 1 is a perfect square. 1 times 2 is a perfect square. By the way, I got 2 from over here. 1 times 3 is a perfect square. I got 3 again from here. 1 times 5 is a perfect square. I get 5 from here. 1 times 67 is a perfect square. I got 67 from here. Are we done? Not even close. Let's keep going. 2 squared is a perfect square divisor. 2 times 3 is a perfect square divisor. So is 2 times 5 squared, perfect square divisor. 2 times 67, perfect square divisor. Let's keep moving on. 3 squared, perfect square divisor. 3 times 5, perfect square divisor. 3 times 67, perfect square divisor. 5 squared, perfect square divisor. 5 times 67 squared, perfect square divisor. All right, almost there. 67 squared, perfect square divisor. And here's where I messed up. I totally forgot about 2010 squared. It divides into itself, folks. It divides into itself. So how many perfect square divisors does 2010 squared have? 16. All right, well, now that we know we have 16 perfect square divisors out of 81, how many ways are there to match 16 of these perfect square divisors with non-perfect square divisors? Well, it would just be the number of perfect square divisors times the number of non-perfect square divisors. 81 minus 16. What is 81 minus 16? Let's do out the math real quick. All right, so 11, 5, 65. So 16 times 65 is the total number of ways we can have a perfect square divisor and a non-perfect square divisor. So this is going to be 16 times 65 divided by 81 choose 2. What is 81 choose 2? Let's do it out. It's 81 factorial over 79 factorial times 2 factorial. And what does that equal to? Well, on the bottom we have 81 times 80 over 2. On the top we have 16 times 65. So 2 goes into 80 40 times. So on the bottom we have what? What's 81 times 40? Let's do out the math real quick. 324. So we got 3240 on the bottom. Actually, instead of doing that, let me write it in its native form. 81 times 40. And on the top we got 16 times 65. All right, so let's see if we can do some math gymnastics here. 4 goes into 16 4 times. 4 goes into 40 10 times. 4 goes into 4 once. 4 goes, oh wait, no. 2 goes into 4 twice. 2 goes into 10 5 times. So I've reduced it to 2 times 65 and 5 times 81. 5 goes into 65 how many times? I think it's 13. So we got 2 times 13 over 81. What's 2 times 13? That's 26 over 81. And 26 plus 81. Remember, this is our m over n. This is as simplified as we can get. 26 over 81 is what? We got 107. And that, ladies and gentlemen, is the answer to the first question. Oh, why is it rotating? All right, well, that's a blooper. So the first question in the 2010 AIME 1. Thanks for checking it out. We'll see you in the next one.
Ambition plus MKO plus scaffolding equal learning. We believe anyone can learn anything. That's why our motto is memorization is a crime. And that's why we partnered with Brilliant.
Brilliant transforms math and science into hands-on activities so that you too can understand everything from first grade math to E equals MC squared. Barry Science Lab and Brilliant is your MKO and will give you the scaffolding to expand your ZPD until you become the next Sir Isaac Newton or Albert Einstein.
Visit brilliant.org/Barry Science Lab today. And the first 50 of you to use that link will get a 20% discount on the Brilliant annual subscription.
Don't forget that you too can become the next Einstein. So let's fall in love with math and science. Alright folks, so here's the problem we got for today. We have 5 books and they have some width. We gotta find the average width of these books. Let's check out the first problem in the 2010 AMC 10A.